Science and technology and innovation, these are indispensable in the modern economy, in the modern world.
We held a meeting at the MSI, and we resolved among about 6 to 8 of us, local members, first to form PAASE Philippines so that we could continue to host meetings here, but also to go on a massive campaign to try to get support from the national government through the legislative and executive branches to invest more in science and technology. So.
Science and technology and innovation, these are indispensable in the modern economy, in the modern world.
We held a meeting at the MSI, and we resolved among about 6 to 8 of us, local members, first to form PAASE Philippines so that we could continue to host meetings here, but also to go on a massive campaign to try to get support from the national government through the legislative and executive branches to invest more in science and technology. So it started with a white paper, a position paper that we co-authored among 6 of us, namely Ernie Pernia, Cesar Saloma, Rador Asansa, Toby Dairita Fateneo, and Aldin Colaba de la Salle, and myself.
So PAASE historically, in the past 10, 20 years for sure, have been collaborating with our counterparts here in the Philippines at various universities. And a lot of these interactions probably started as peer-to-peer. But thankfully, we have the Department of Science and Technology here in the Philippines, and they've come up with some really helpful and very impactful programs that actually enable PAASE members that are based in the United States and other parts of the world to actually come here and do extensive research and academic partnerships and collaborations.
Well, I think that one of the good things that PAASE is doing is really trying to stay in touch with the researchers and the scientists here in the Philippines. So I think that is one of the good programs that they keep on supporting some of the initiatives of our researchers and scientists here in the country, trying to align also their assistance towards the plans of the Philippine government.
It's very important that the PAASE members and scientists based in the Philippines are continuously in contact, so we will know the needs of the Filipinos and opportunities that Filipinos can have to do science with their PAASE counterparts. So these interactions, such as the conference that we're holding and the annual conferences that we have.
The Philippines and the scientists there have very unique perspective that adds to discoveries and inventions, advancing in general the field.
These members, because they are part of an academy, it implies that they are productive. So they have publications, they have innovations, they have inventions, patents, and they have, they have an impact on society. Okay, so these are the people who can convince government, invest more in science and technology. And that was really the gist of our paper, our position paper in 2000. And it is Ernie Pernia who said that R&D by nature is expensive and it is a public good. So it is important for the government to take the lead in investing in R&D.
To increase the economic growth potential of the country, we cannot continue to just rely on traditional inputs into production as capital and labor. We also need to develop our expertise in science and technology and innovation so that we can come up with new systems, new ways of doing things.
I think that science, researchers, industry, and even the government is really like an ecosystem of knowledge. So I think it doesn't really matter if you're coming from a private institution or a public institution, such as a state university. I think we all have a role to play to improve the research capabilities and scientific knowledge here in the country. I think it is about time for us to realize that one of our roles as academics, as researchers, as scientists, is to actually contribute to that global body of knowledge.
And the role of this cooperation among these government agencies really is to be able to attract science and technology, global-based companies to set up shop here. And that is really key in terms of developing the science and technology innovation ecosystem in the country.
Particularly because there's that deep desire. And what PAASE does and can do more of is to promote this relationship between its members.
We really need to ratchet up the appreciation, the recognition of the importance of science and technology and innovation.
And we are all trying to attain what we call the common good, the greater, higher, long-term good of the Filipino people.
Science and technology and innovation, these are indispensable in the modern economy, in the modern world.
The meeting at
Doc Wang?
Yes, yes. Shall we begin?
Yes po.
Okay. Have you let the people in already?
Yes, Doc. Yung
Okay.
iba siguro susunod na lang.
Okay. Yeah. So, good morning, everybody. Good morning, good afternoon, good evening from wherever you may be. Welcome to the PAASE webinar series. Today we have a quite interesting topic. I'm Wang Romana Igia of the Southeast Asian Fisheries Development Center Aquaculture Department, and I'm a PAASE member. I'll be moderating today's webinar. So, but before we begin, let me just state some house rules. Okay. First, mute your microphone when you are not speaking. Second, all comments and discussion should be respectful. Use the raise hand function during the Q&A. Use the chat box responsibly and limit questions related to the webinar. So today's talk is about the silver therapon or ayungin, which is an indigenous species found in the Philippines. Some trivia about it is that it's our national hero's favorite fish. So the ayungin is quite valuable to us. And today's speaker is Dr. Frolan Aya. Will talk about the breeding and hatchery rearing of indigenous freshwater fish species, the silver therapon or ayungin. So let me introduce our speaker. Dr. Aya is a scientist and head of the Binangonan Freshwater Station of Deck Aquaculture Department. He obtained his BS in Fisheries degree at the University of the Philippines in the Visayas on a BFAR scholarship. He has an MSc and a PhD in environmental science, both from the Hokkaido University in Sapporo, Japan, as a Monbo Kagusho, or the Japanese government scholar. He was a postdoc fellow in fish nutrition at the Department of Marine Biomaterials and Aquaculture, or Feeds and Foods Nutrition Research Center at the Pukyong National University in Busan, Republic of Korea, as a National Research Foundation of Korea grantee. Dr. Aya was awarded the 2019 Outstanding Young Scientist in the field of environmental science by the National Academy of Science and Technology, Philippines. His research interests are on the breeding, seed production, nutrition, and development of aquaculture feeds for freshwater fish species. So let us all welcome Dr. Frolan Aya.
Yeah, good morning, everyone. Good evening, good afternoon, dear fellow Filipinos. So just share my PowerPoint. So, first of all, thank you to the PAASE for giving me this opportunity to share the results of my study on the breeding and culture of one of the native freshwater fish species in the country, silver therapon or ayungin. Well, as mentioned by Dr. Wang earlier, it's Dr. Sericel's favorite fish. It's considered as one of the tastiest among all the freshwater fish species in the country, which can explain why it's known to be Dr. Rosario-Sal's favorite dish. And eating ayungin is considered as part of the tradition of the consuming public, particularly for those who are 60 years old and above. And this is it's a source of income for small-scale fisheries in the country. So in terms of its biology, so the scientific name of ayungin is Leopotherapon plumbeus. It's also locally known as licao. It can be distinguished with its shiny silvery color with yellowish tail. It's a relatively small fish. It can grow up to a maximum size of 15 centimeter. But now the usual size common in the market range from 6 to 8 centimeter. So it comprised the subsistence fishery in lakeside communities, and it commands a good market price, about 200 to 800 per kilo. So it's 5 times more expensive than tilapia and milkfish or those. In the Philippines, it's widely distributed in Laguna de Bay, in the neighboring, or particularly the provinces of Rizal and Laguna. And it has been translocated to adjacent lakes such as Taal Lake in Batangas, Sampaloc Lake in Laguna, and even one lake in Mindoro. This species has been recorded also in inland water bodies in the northern part of the Philippines, and as well as Candaba wetland in Pampanga. It's considered bycatch or accidental fish harvested from cages or pens. And because of its small mouth size, they are caught with gill nets. It can also thrive in brackish water, and in fact, it's considered a pest by shrimp growers in Pampanga because they enters the brackish water where they feed on shrimps, cultured shrimps such as barnacle or mother. Ayungin is a slow-growing fish. In captive conditions, they can grow from an initial size of 51 millimeter and 2 grams to 114 to 123 millimeter and 28 to 32 grams in a span of 16 months culture. Generally, females are bigger than males, and the minimum size maturity is influenced by the limnological conditions of the lake habitat. The wild therapon from the Taal Lake reach sexual maturity at 70 millimeter and 80 millimeter for females and males, whereas in Sampaloc Lake, an estimate of 60 millimeter and 50 millimeter for females and males were observed. But hatchery bred silver therapon can reach sexual maturity after 8 months, which are 20 grams and 100 to 105 millimeter in size. In terms of its feeding habits, they are considered as omnivore species, meaning they both feed on phytoplankton and zooplankton, and they have a relative gut length of 0.47 to 0.53. Zooplankton is important the diet of smaller fish, whereas the crustaceans, fish, and aquatic insects are consumed with the larger fish. So you can see here the intestines of the ayungin. Ayungin used to be the major fish caught in Laguna de Bay, like in the 1960s to 1970s. Approximately about 70% of the total fishery catch, but now it only comprise 1.7 of the total fishery catch among the commercially caught freshwater fishes based on a paper of academician Dr. Guerrero. And it is alarming to note that the ayungin has been reported to have the highest decline rate among the freshwater fish species caught in the Philippines. Indeed, based on the data of the Philippine Statistics Authority, there was a significant downward production trend of ayungin from by as much as 75%, from 4,765 tons in 2002 to 1,182 tons in 2020, which correspond to more than 50% decrease in value. Intense fishing pressure and more recently the introduction of invasive alien species have contributed to the decline of ayungin. And this has significantly affected the livelihood of small-scale fishers along the Laguna de Bay area. And because of the decline in the production, it is now considered as vulnerable species. So because of the significant decline in the production and the popularity of ayungin as a food fish in the Philippines and the importance in the lake subsistence fishery, this has led to for Seafood Aquaculture Department to develop breeding techniques and hatchery techniques for domesticating this Philippine native species. I should also mention the pioneering work of UPL Meteorological Station on the breeding and hatchery breeding of this species, as well as the current efforts of state colleges and universities such as Bataan State Peninsula University and National Fisheries Research and Development Institute. They are also working on reviving the production of this very important commodity. In terms of reproduction, ayungin has the potential to reproduce throughout the year, but they have peaks during the onset of the rainy season starting from March to May. And considered as a reliable method of obtaining higher number of larvae in the hatchery, so artificial breeding of ayungin requires the use of exogenous hormones or synthetic hormones to promote the maturation and spawning. And nevertheless, natural spawning of this species has been documented also in our facility during the peak of spawning season based on the observed presence of larvae and early stage fingerlings. But the problem is a limited number of fingerlings. So how do we distinguish the male from the female ayungin? So based on external morphology, the females have the oval shape, they have the short fleshy tubular extension of their genital opening, whereas the male, they have a round genital opening and is marked by the release of the milk when we apply slight pressure on the abdomen. But can also distinguish through cannulation by inserting the genital opening to examine the presence of eggs and milk. So the successful artificial breeding of ayungin requires the use of hormonal treatments. So the spawning of ayungin can be done or can be induced by a higher concentration of human chorionic gonadotrophin at 50,000 IU per kilogram body weight, or the application of salmon gonadotrophin releasing hormone analog at 20 microgram per kilogram body weight. So those are some of the hormones that we tried and tested in the hatchery. However, the efficiency of lower HCG concentration, or in combination with ovaprin, for example, which is the use one or the common hormones used in fish breeding, and the use of the domperidone or dopamine antagonist have not been examined in a as well as the determine the age of silver therapon when they are still or can be used in the hatchery for optimal breeding efficiency and seed production. So we have published a paper in the Journal of Applied Ecology examining the effects of this of the exogenous hormones in performance of the different age groups of domesticated silver therapon. So we have tested these hormonal preparations to consideration of HCG, single injection ovaprin, and a combination of HCG plus ovaprin and HCG plus domperidone. And we have a control, which is a saline injected fish. Ovaprin is a complex of salmon gonadotropin releasing hormone, which stimulates the release of the gonadotropin from the pituitary, and domperidone, which is the dopamine antagonist. And just to show you our protocol, so we're using 2-phenoxyethanol as a sedative solution or anesthetic solution to immobilize the fish before doing cannulation to obtain samples of the oocyte to check the sexual maturity. So a diameter of 300 to 400 is already suitable for use. And then we measure the body weight to estimate the volume of hormones to be injected to the captive broodstock. And then we injected the hormones intramuscularly, both to males and females. And then we transferred the hormone-treated fish at the sex ratio of 1 female to 2 females in spawning packs and monitor and spawning. Normally, the spawning occurs between 24 and 33 hours, but it depends on the water temperature. And the eggs are demersal. They are transparent or yellowish, as you can see in this slide, and there are slightly adhesive. So, and the eggs are collected 2 to 4 hours after spawning, and then incubated them in round plastic basin until hatching. So regarding the results of the hormonal treatments, it shows that silver therapon respond better to more than one kind of hormone, such as the HCG and ovaprin, HCG plus DOM, as shown by the 100% spawning success, and that the injection of a single hormone may be not sufficient to promote maturation and spawning of the ayungin. The results also showed that a significant difference in terms of the fecundity, or the number of eggs per gram female, which produce more eggs in the HCG plus ovaprin. Similarly, the fertilization and the hatching rates were very high in this hormonal treatment combination, as well as the number of larvae per gram female. And using the best hormonal preparation, the reproductive performance of the 4 age groups of domesticated silver therapon were also examined. And our results show that the broodstock age influenced the spawning success with higher percentage of the 1-year-old compared to the adult, the more older captive silver therapon. This present study also confirms previous results that broodstock age or fecundity increase with broodstock age, shown with the higher number of eggs among the older captive broodstock. And although the fertilization rate and the hatching rates decrease with broodstock age, the difference were not significant, suggesting that domesticated silver therapon broodstock up to 4-year old could still be used for breeding and seed production. Information on the early life history of ayungin is also very important in understanding the biology of this species. And we were able to document the embryonic development, which is completed 21 to 24 hours after fertilization at 27 to 28 degrees Celsius. And also the larval development. So I could show you the video of the 1-day-old. Sorry, it's not working. Yeah, this one. So it's already 1 year old, so the eyes are already pigmented. So you can see it's still very tiny and transparent. So that's how small the human larvae are. And well, the larvae of ayungin is very tiny, as I mentioned. They have no functional or pigmented eyes or mouth or digestive tract, which are critical features for first feeding. And indeed, attempts to rear them in the hatchery, in the indoor hatchery, resulted or is marked by mass mortalities, particularly around the time when the exogenous or the endogenous yolk reserves are completely consumed at 2 days post-hatch. And also the fast yolk resorption rates, which we observe at 39 hours post-hatching, will make them sensitive to irreversible starvation. So because of the mass mortalities that we encountered in indoor larval breeding, so we thought that probably we can prevent or avoid the loss of hatchery larvae when we rear them in outdoor tanks. So these are the management strategies that we conducted. One is the use of the preconditioned reading tank water, and then the fertilized tank reading water, and the use of lake water with Talisa gives as a physical substrate. So in this strategy, so we conditioned the water for 2 weeks to allow the growth of the phytoplankton and zooplankton. And we were able, the larvae were successfully reared up to the juvenile stage. And this is the first successful or hatchery rearing trial. However, the survival rates at 12%, we considered it still very low and consistent. So probably because of the low density of the food items in the preconditioned drinking water, or there's a need to manipulate or to optimize the stocking density of larvae in outdoor breeding tanks. So we did fertilization of tank feeding water by applying inorganic and organic fertilizers 5 days prior to stocking for 4 to 5 days thereafter, just to accelerate the growth of the plankton. And we also tested 2 stocking densities at 750 and 1,000 larvae. And our trial showed that we an improvement in the survival after 30 days of breeding from 12% using the preconditioned water to 35% using the fertilized sleeping water. And the suggested the optimum stocking density is 750 larvae per time. However, we wanted to further improve survival, and we thought that the water under natural lake conditions would be a better environment for the larvae to survive compared to the condition and the fertilized lake water. As lake water contains adequate or enough zooplankton densities that could promote the survival and growth of the ayungin larvae. And well, the early survival of larvae are dependent on the abiotic and biotic factors such as temperature, the type, and availability of food. But recently, the effect of the breeding environment have caused also some mortalities in the larvae. And there have been some studies on the use of or modifying the breeding environment by applying or adding physical substrate to improve the survival of the captive reared fish larvae. So in this study, we tried to use the talisay leaves or the tropical almond leaves. It has been reported to stimulate breeding, wound healing. It has bacterial and antifungal properties and can promote growth, survival, and fish and crustaceans. So the aqueous extract, which contains the phytochemicals, are known to enhance water quality, reducing water pH in ammonia. But unlike in previous study, which used the extract, we just allowed we add the talisay leaves in the breeding tanks and allow them to decompose during culture. And interestingly, the presence of the talisay leaves significantly improved survival up to 48%. So the presence of the substrate would be serve as a substrate for the serve as a substrate for the benthic food items to colonize and to be consumed by the ayungin larvae. And although I have not included the data on the water quality parameters, but it also improved the presence of the talisay leaves also improved the quality of the drinking water. And the darkening of the lake water also provided a good background for contrast for the larvae to efficiently capture its prey, and that contributes to better feeding success and consequently the improved survival of the ayungin larvae. The growth, however, was not significantly different between tanks reared with and without the physical substrate or talisay leaves. We also documented the diet composition and a lot or mixed organisms that were ingested by the ayungin larvae, suggesting that they are generalist predator, but they tend to show some degree of selectivity for some food items during development. So the major items, food items important in the diet are the Copipadnocli, and to a lesser extent, rotifers and the water fleas of the early stages of moina. However, as the silver therapon increase in size, the larger food items such as the Caladocerans, the Bosmina perigoni, and also the ostracods and the insect larvae increase in the diet, suggesting a shift in the diet of ayungin during ontogeny. So just to highlight the effect of the breeding waters, so from 12% using the preconditioned water to 35% using fertilized water. So we obtained 48% survival using lake water, and the application of Tanisa gives it's a modification to improve the survival of ayungin hatchery. And this information served as a foundation for further research on the suitable live feeds, no, in the development of the workable hatchery protocol for ayungin. And we were able to publish a paper in Philippine Agriculture Scientist Journal, where we tried using the urea rotted first as starter food, because ayungin also thrive in brackish water, and we were able to develop a feeding regime which consists of the chlorella, the rotifer, Brachionis, rotundiformis, and Artemia. So way forward, right now developing, working on the development of nursery and grow out breeding techniques, as well as the development of diets for ayungin during the grow out culture. And I hope we will be completing these experiments this year. And it's hoped that through these interventions, the production of the sufficient supply or number of viable seeds of ayungin may help secure food security. And we wanted to demonstrate this hatchery technology to more than small-scale fishermen through training and possibly the distribution of fingerlings, so that they can have sustainable source of livelihood and income, and alternative livelihood, such as the nursery and grow out, similar to the notable species such as the big-head carp, tilapia, and giant freshwater prawn. And ultimately, we want to revive the production of these species to increase the local fish biodiversity, and to help promote the BIFAR Balik Sigla Sigilog and Lawa program to repopulate or restock indigenous species in major lakes and rivers in the country. So before I end this talk, I would like to thank SIFDEC assistants, Dr. Luigi Garcia, who's my collaborator in this study, for the past 12 years doing research on this species, and the UP Diliman Institute of Biology. So thank you very much for listening.
Okay. Thank you, Dr. Aya. I guess now we're ready for questions from our listeners, our participants. If you have any, you may either ask them yourself, or you put the questions in the chat box. So, but at this point, I'd like to congratulate Dr. Aya for all his accomplishments as regards the hatchery breeding, hatchery technology for the ayungin. But of course, as he mentioned, it's not only SIFDEC who's working on this species. We also recognize the efforts of UPLB, and NFRDI currently is also working on the ayungin. And I guess based on his presentation, there are still a lot more studies that are needed. I think ayungin presents itself as a rather difficult species to work on. The progress is not as fast as the other commercial species, but the efforts of Dr. Aya is quite laudable. So we should at least see that as a way of really moving forward. It's you mentioned it's a highly vulnerable. It's already considered as a vulnerable species, no? So I only hope the government pays a lot of attention to this in terms of coming up with conservation and management projects. So although I'm sure now, like the Bureau of Fisheries has their balik sigla sa ilog at lawa, and I hope I really believe that they have this on top of their list. Okay. So should you have questions, Dr. Aya would, I think, gladly answer them. I have a question, Doc Fro. You
Yes.
mentioned there are some lakes where the ayungin has been translocated. Would you know where these are, and would you know any updates as to the status of the maybe was it successful when it was translocated, or what?
I think yeah, has been translocated like the Taal Lake in Batangas, Sampaloc Lake, and one lake in Mindoro. But I think there have been no research done on these species and those particular lakes. No? But maybe it's not yet popular among the the locals there. Maybe there are more, or they are preferred other species for consumption. But I think, I think in Mindoro, they are working on the goby. It's another indigenous species. But I think there's a demand for fingerlings like in Mindanao and other parts in the country. So I think the problem is still the limited number of the viable seeds of ayungin, but we're hoping to further scale up the production and also disseminate the technology to interested. Like before is like region 2 is asking for our technical assistance on the breeding and hatchery techniques of this species. So we hope to disseminate this not only in the northern part of the Philippines, but in other areas in southern Luzon where ayungin is abundant.
Thank you, Doc Fro. There's a question in the chat box from Vic Ilag. He said, sorry, I was late, so I might have missed it. What is the fatty acid profile of ayungin, especially with regards to omega-3 and omega-6 fatty acids?
We have, that's a good question. Where's to date, there are still no studies done on the proximate. Although I have some preliminary data on the proximate composition analysis, but for the fatty acid analysis or the composition, I have some data, but we're still reviewing it, and hopefully submitted for publication. But I think it's more of the N6 fatty acids, but there's a difference between those reared in the hatchery and those caught from the wild. So we're still reviewing or analyzing our data, and also to discuss what are the possible reasons for the differences in those composition. But for the proximate date analysis, the wild caught female and males have higher CP content compared to the hatchery bred counterparts. Probably they are feeding on nutrient-rich food items present in their natural environment. But in terms of the lipid content, the hatchery bred have higher levels. Primarily because we're feeding them with diets containing high levels of lipids. And also the swimming activity of the stocks. So in a natural environment, so the swimming activity mobilize the lipids, so they have a lower lipid levels compared to the hatchery bred stocks that are confined only in tanks or in cages, so they have very limited movement. So the lipids are like they are conserved. That's why they have higher levels of lipid. So yes, we will inform you once we have the information of the fatty acid composition of this species.
Yeah, thank you, Doc Fro. Any other question? I noticed that you did the study on diet composition. Was it done on wild caught fish, wild caught ayungin?
For hatchery bred larvae.
Okay, so the one that you showed us with the different planktons and other food items, those are basically using fish coming from your hatchery bred stocks, but
Yes,
reared, those are reared in the lake.
lake water,
Okay.
in outdoor tanks with using lake water.
Okay, okay. Yeah. Okay. Any other questions? By the way, Dr. Aya, we're proud to say that he owns the patent. He is the first to patent the technology on the breeding, right, Doc Fro?
Yes,
Breeding of the ayungin.
like
And
after 8 years.
so Mr. Ilag asked, where else are the patents filed?
The patents was filed only in the Philippines. So the IPO, the Intellectual Property Office of the Philippines, awarded the patent. I think last 2019 only.
Was there any other patents filed elsewhere? Would you know of any studies outside of the Philippines that would have a similar accomplishment, or
I have
none?
no information on it.
So it's the first in the world. So you have to have it filed at WIPO, World Patent Office. Uh, so yeah, it's I think no, it's a rather challenging species to work on. But I guess like most other indigenous species, really it takes a while. But it's very important work, as we all know. So we congratulate you for that, Doc Fro. And I think no, like in this webinar, I hope the others who are listening, who are interested to work on it, you can do a lot of collaboration, if not with Dr. Aya, with the other agencies that are also working on the Lepotherapon plumbeus. And I know, are there other species, indigenous species, that you're working on currently, Dr. Aya?
Um, Working on
Or-
the flying perch already. So we already submitted also a manuscript for the reproduction and up to the larval reading of this species. So will it get published soon? And I'm also interested working on the goby species. Well, although before Tanay is also have some current studies on the breeding in the hatchery as well as the Mindoro State University. And I think UPLB Limnological Station has previous study on the breeding and breeding of goby. So hopefully have the opportunity to work on some of these species or to collaborate with other agencies already working on this on goby species. And there are a lot of indigenous species that are now facing serious depletion. So
Correct.
before they can be become extinct, so we have to do some studies like basic studies to have information on the biology of the species and work on later on the culture and possibly for restocking national waters.
Okay. Yeah, so I agree with you, Dr. Aya. I think it's high time that we move forward with the indigenous species, more so because we have a lot of them. So the level of biodiversity within the Philippines alone is quite high, and it's a pity if we don't get to do a lot of research on our own species. It's sad. It's sad to note that many of our, no, not many, but some of our people from the other sectors would rather get or import species coming from outside and commercial and develop them as commercially valuable species. But I think what perhaps Vietnam and Thailand did with their pangasius, we can also do with our own indigenous stocks. So there. So are there other questions or maybe comments that you would like to ask Dr. Aya? Okay, I guess there's another question that I have. Perhaps you mentioned that the ideal age
Yes, ma'am.
for induced spawning would be at a year old ayungin, right?
Yes,
And beyond that, the hatching rate, is it?
Yes, but they hatched the
becomes low. So what do you intend to, what would be a recommendation? Would you recommend the older stocks, or up until what age should one use as broodstock in the case that you have already figured out what ideal age should be used?
Well, although there was a reduction, or there were reductions in the fertilization hatching rates up to the 4-year-old, but still the differences were not significant. So we can still use the up to 4-year-old rootstock for induced spawning. But if we want to have more or higher fertilization and hatching rates, so we can use 1 or 2-year-old, or more, one and a half year for the breeding program activities.
Yeah, as regards to the sex ratio, you mentioned you use 1 female to 2 males. Have you tried other sex ratios as well? Maybe I would guess that using 2 males would give you an assurance that the female would get to be the spawn would get to be fertilized. So have you done any other work to probably look at other sex ratios to optimize?
We have tried like 1:1 ratio, but still it shows that 1:2, one female to 2 males sex ratio is still better compared to the 1 female to 1 male. So, because generally the females are bigger, so we have to size match the size of the male and the female, and usually we have bigger females, so we have to use 2 males to ensure the good fertilization and hatching rates.
It's rather strange, no? It's a female that's a lot larger, because in other species it's the males that are a lot larger than the females. Okay, so are there more questions? I only hope the other participants would pose their questions now, or if not, you can easily contact Dr. Aya. He and I are in the same station, Binonan Freshwater Station. So for any interest in collaboration, I know, like if you belong to the academia, you can easily file or submit proposals for DOST funding. If you're with DA, you can do that as well with their funding agencies like the DA bar. So, and I know now the DA bar is also supporting several work on indigenous species, the propagation as well as the production. Okay, so if there aren't any other questions, I hope the admin is ready with the certificate for Dr. Aya. Okay, so at this point, on behalf of the PAASE President, Dr. Mariano Santo Domingo, PhD, sorry, the Philippine American Academy of Science and Engineering presents this certificate of appreciation to Dr. Frolan A. Aya for graciously sharing his expertise in his talk entitled Breeding and Hatchery Rearing of Indigenous Freshwater Fish Species, the Silver Therapon or Ayungin, during the PAASE webinar series organized by the Research Expertise Cluster Council, given this 25th day of November 2022. Signed, Dr. Mariano Santo Domingo, PAASE President. Congratulations, Doc Aya.
Thank you very much.
Okay, so before we end, let me just make an announcement for the next, I think it's the fireside chat. Yes, I hope the participants in this webinar are able to attend as well. The PAASE Fireside Chat, which happens on November 30, 8:30 a.m. Philippine Standard Time. And the theme is on Aling Wikang Panturo para sa Agham at Matematika, a conversation on the issue of medium of instruction in science and math. The speakers are Dr. Gregorio Del Pilar, President of the NRCP, Dr. Diane Decker, of the, sorry, I cannot read. It's so fine. Okay. She is a senior literacy and education consultant of the Summer Institute of Linguistics. Another speaker is, the moderators for this session would be Dr. Mariano Santo Domingo and Dr. Ricardo Nolasco. Reactors are Dr. Fortunato Sevilla, Professor Emeritus of UST, Dr. Alan Bernardo, Distinguished University Professor of DLSU, and Dr. Giovanni Malapit, Assistant Professor of the UP University of the Philippines, Baguio. So hope you can attend this as well, and we'll see you in the other activities and events of the PAASE. Thank you very much for attending.
Doc, pwede po, photo.
Ay, sorry. Before we all leave, let us have a photo a session. I hope that, thank you for reminding me. So let us all turn on our videos if possible. Yes.
Okay po.
I hope the others can turn on their videos while waiting for our admin to take a photo of maybe their videos are quite weak. Yeah, please. Yes. Oh, I see Raylan. Our colleague Raylan. What about the others? Oh, I see Irene as well. Yeah. So this might serve as your certification that you attended the webinar.
Sige
Okay.
po.
Okay.
1, 2, 3, smile. Another one po.
Yeah.
1, 2, 3, smile. Okay na po.
Salamat.
Thank you, Doc
Yeah.
Wen.
Welcome. Thank you, and I hope you have a nice day. Enjoy your day. Thank you.
Thank you po.
Okay.